Hey mathematicians, let's talk about factors and how do we find the factors of a number. Starting with some vocab. This one's super important, we should already know it, we've talked about it before. A product is what we call the answer to a multiplication problem. So you can see here we have 2 times 9 equals 18. 18 is our product because that's the answer. The numbers that are being multiplied together, the 2 and the 9, they're called the factors. So you can have loads of factors if you do like 2 times 9 times 7 times 4 times 13, and you have your answer, your product. All of those numbers can be factors, but for the most part, we usually just have 2 factors in a multiplication problem, especially when we're talking about factors and factor pairs. Because when I ask you to get into pairs, it's 2 people. So we're going to be focusing on 2 factors equal a product, factor pairs of a number today. How do we show our factor pairs? There are lots of different strategies. You can use a t-chart. So here we have our factors listed, and we know if these are, we're looking for factors of 18 here. That's our example number. Where is my little, oh wow, it's up there. 1 times 18 equals 18, 2 times 9 equals 18, 3 times 6 equals 18. You can list them like that. You can list them, in my personal favorite, a factor rainbow, which we'll talk more about how to build in a second, but you can see that 1 is connected on the rainbow with 18 because 1 times 18 equals 18. 2 is connected on the rainbow with 9 because 2 times 9 equals 18. You can also use area models. So you can see here that this one has a height of 1, and it's 1, 2, 3, 4, 5, 6, it's 18 across. So your total area, you've used up 18 squares to show this particular area model. If you have a 2 by 9 rectangle, that uses up 18 squares to build this rectangle. Or a 3 by 6, again, that uses up a total of 18 squares to make factors of 18. So these are the area models that create 18. Let me ask you, is this one here, this long skinny rectangle, different or the same than, whoa, what is that? Did not mean to do that. Then this one. I mean, they look kind of different, but are they really different? Is that 2 by 9 really different from this one? Or the 3 by 6 really different? It's kind of just the same thing, just tilted 90 degrees. So would I really want to say that the factor pairs of 18 are 1 times 18 and 18 times 1? That kind of seems like you're writing the same thing and it's just extra work for you. We don't want that. When we list factor pairs, we only want to see what are called distinct factor pairs. That means no repeats, just like flipped. And when you flip them, there's actually a name for that in math. It's called the commutative property of multiplication. And it's the rule that says, like, if you do 2 times 9, that's the same thing as 9 times 2. Same answer, it doesn't matter what order it's in. And that applies for if you have 2 factors or 3 factors or 21 factors. So long as it's all multiplication, you're going to get the same answer. This word, maybe you can think of it as you commute to school or to work. You probably go the same way. It's just, here's your house. Oh gosh, I didn't mean to give this example. I'm going to draw it. Here's your house. Here's school with our front doors. When you go from your house to school, you go this way. And when you commute and on the way home, you're going the same distance, just a different direction. This way, doesn't matter, you still walked the same amount or drove. That's the commutative property. So we don't want that. We just want distinct factors when we list our factors or factor pairs. So those are 2 different things. If I ask you to list factors versus if I ask you to list factor pairs. So let me show you both ways in an example. Let's say I asked you to list the factors of 36. My personal favorite way to do this is in a factor rainbow. So I get nice and big because some numbers have loads of factors. I'm going to draw a big rainbow here. And I like to go in order from least to greatest because that helps me make sure I've got everything. So I'm always going to start with 1 because 1 is a factor of every number. 1 times what equals 36? 36. 1 and the number you're finding factors for will always be factors. Maybe you'll have other factor pairs, maybe you won't. But I'm going to put a little comma right here, and I'm going to think, can I do 2 times something equals 36? You might want to think back to our divisibility rules. 6 is even, so I can divide it by 2. So even if I don't know off the top of my head what it is, I know that there is going to be a factor pair. 2 times 18. Right? Yeah. Keep going. 3 times 12 is 36. So notice how I'm connecting them nicely, and I should be putting commas on this side too. 4 times 9 is 36. 5 times, I know this does not end in a 5 or a 0, so 5 times nothing. But I'm still going to keep going through them and checking them in order. 6 times 6. Ooh, okay, so here's the confusing part. I only want to list distinct factors. And you can't really be your own partner. So I'm just going to leave 6 in the middle without a rainbow connection, because 36 was actually, think back to our exponent lesson, a square number. But it is 6 times 6. So if I asked you to list me the factors of 36, this is your list right here. 1, 2, 3, 4, 6, 9, 12, 18, and 36. If I asked you to list me the factor pairs, and I will switch up what I'm asking you for, so you want to make sure you know both. If I asked for the factor pairs of 36, then you'd list it like this. Let me put a title on this. Where's my thing? This is just factors. This is a list of factor pairs. Pairs means 2 together. So I would say 1 times 36, that's a factor pair. 2 times 18, that's a factor pair. 3 times 12, that's a factor pair. 4 times 9, that's a factor pair. And 6 times 6. So this is not 2 distinct factors, but they do make the factor pair. So if I'm listing factor pairs, I do want to have that 6 times 6. If I'm just listing distinct factors, I'm only going to list the 6 one time. And those are our factors and factor rainbows.